Good morning, guys. I just wanted to touch base with you and go over the Section 3A notes very quickly and just offer some insight for you so that it will be a little bit easier for you, not very much. The first thing is I wanted to show you, this is the periodic table that I normally give you. On your assignment page, I did put the file on there for you for this one. But I just wanted to point out that you see here in the middle, it gives you a good key for what's in each box. And then down here, there's also a key that tells you if it's a solid, liquid, or gas at room temperature, if it's radioactive, and if it's artificially made. It also has the metals on here, and it also has the non-metals. And also with this key, like here it tells you the atomic number for this particular periodic table is right here, but it also tells you that it's the number of protons and the number of electrons. When we are in class face-to-face, I have copies of this periodic table that I give you while you take the test. So this is the one that has lots of information on it. Any periodic table developer or creator can make it however they want to make it. They don't have to put the atomic number in the upper left-hand corner. They can put it anywhere they want. Okay, you just have to look for the key. But I wanted to show you, this is the one that I embedded. You have one in your agenda. There are hundreds on the internet that you can use. Okay, but this is the one that I feel is best for our needs. Then we have the notes for atomic structure and isotopes. I am not going to go over everything because you can copy my notes or you can just print my notes, whatever you would like to do. But we've talked about elements again. We're just going to hit some high points. We've talked about elements before. We're going to talk about them again. Elements, remember, is matter that is composed of one type of atom. It is a pure substance, so it's pure. Okay? It's abbreviated in a scientific shorthand that we call its chemical symbol. And its first letter of that symbol is always capitalized. Always, always, always. If it has a second letter and or a third letter, those have to be lowercase letters. They have to be. Okay, this is not a Birch rule. This is chemistry rules. So I give you some examples there of copper, uranium, oxygen, zinc. Oh, I'm sorry, I said copper. Carbon, uranium, oxygen, zinc, copper, and iron, just so that you can see. You have to write a capital letter and then a lowercase letter if there is more than one. Then an atom is the smallest part of that element, okay? And it's made up of 3 different parts, subatomic particles we call them. I know that you've done this before because I've talked to Mr. Brian and he says that you guys have done this. So you have protons, neutrons, and electrons. Those are the 3 subatomic particles that we are going to look at. What I want to point out to you is here, these are the abbreviations. Okay, those you want to make sure are in your notes. That will save you lots of time and energy down the road. You see that the protons and neutrons are located in the nucleus and that the electrons are located in the electron cloud around. And then the charge, I just want you to understand that before you've been taught that a proton has a positive charge, and that is a true statement. I want you to take it a step further this time and understand that it has a positive 1 charge. Same thing with electrons. It has a negative charge, that is true, but it is a negative 1 charge. And also with chemistry, I want to point out to you that you have to put the plus or minus signs. I know in math that if there is no sign, it's assumed to be a positive. You cannot do that in chemistry. You have to put the positive sign if it's positive, okay? So next here, I just have the nucleus, and I drew a picture so that you could see. And what I do is I color coordinate everything. I've told you that before. But the nucleus is in the center. It contains the protons and the neutrons. I highlighted that in orange. So I highlighted it in orange here and made a little drawing. The electron cloud is around the nucleus. I highlighted in yellow, and so I highlighted my drawing in yellow so that we could see those, okay? Another thing that I'm not sure if I have it typed on your new ones or not, but each orbital has its own shape. And so if that's not written on yours, you need to write it on there. That is important. But I'd like to show you real quick. Here is an electron micrograph of electron orbitals. And this is above the scope of this class, but I just want you to see they have different shapes, okay? And it's not anything that we're ever going to be able to see or study in this class. But that's important for you to know, all right? For your second page of notes, we have quarks that I just wanted to mention, okay? So they're in your notes. There are other subatomic particles at this point that we believe we have discovered, but again, it's beyond the scope of this class. So I just wanted you to have heard the word. We are going to focus here on atomic mass and atomic number very quickly. So the atomic mass is the mass of the atom. Imagine that. But it's focused mostly on the protons and the neutrons, the mass of the protons and the neutrons, because the electrons are so infinitesimally small they don't count. They do have mass. They are matter. But they're so puny that they just even don't count in the mass. So the protons have a mass of 1. Neutrons have a mass of 1, and they're both found in the nucleus. The atomic mass we can also call the mass number or the atomic weight. I don't like using atomic weight because we know that mass and weight are not the same thing, but that's how I learned it 50 years ago, and that is the only thing that I don't like about your periodic chart is it still calls it the atomic weight, but any of those are okay. So if you're mathematically minded and would like to see a equation of that, the atomic mass equals the number of protons plus the number of neutrons. So if you're given 2 of those 3, you ought to be able to find the third. Okay? So let's just practice that for 1 minute. Oh, well, not yet. Let's not do that yet. Okay, so the second one that we need to look at specifically is the atomic number. The atomic number is the number of protons in the atom. And the number of protons is the identifier. It identifies who it is. I like to call it its fingerprint. Okay? So it will tell you who it is. If it has 6, for example, protons, it has to be carbon. If it had 5, it would be boron. If it had 7, it would be nitrogen. It tells you who it is. It is the identifier. It is also the number of electrons in a electrically neutral atom. And for right now, all of our atoms and what we're going to be talking about is neutral. So the atomic number is the number of protons and it is the number of electrons. Okay? So if you go back now and we look at the periodic table that I'd like you to use, you see here again the atomic number is on this periodic table is in the upper left-hand corner. And it says the atomic number is the number of protons and it is the number of electrons. So on a test, how easy is this? When I say, like cobalt, how many protons does cobalt have? Well, you find cobalt, you see that it has an atomic number of 27. It has 27 protons. That's all you do. So I'm not moving this around. Hydrogen has 1 proton. Lithium has 3. Sodium has 11. Potassium has 19. Rubidium has 37, etc. Okay? The atomic number is the number of protons. And for us right now, it's also the number of electrons. Okay, so because all of our atoms are going to be electrically neutral until we bond them. So remember, protons are positively charged, electrons are negatively charged. And so if they equal each other, it doesn't matter what element that you choose, it will have a 0 charge. So for example, we have lithium. It has 3 protons and 3 electrons. Plus 3 minus 3 equals 0. Sodium has 11 protons for a plus 11 charge. It has 11 electrons for a negative 11 charge. Plus 11 minus 11 equals 0. We will go over that again, okay? But I just want to show you that because you see here, tell me why the atoms are electrically neutral. It's because the number of protons equals the number of electrons. Protons are positively charged, electrons are negatively charged, so that's why they're neutral. Okay, so on this periodic table, the symbol is in the middle. The name of it is underneath the symbol, and then in the middle of the bottom is the atomic mass, which is the number of protons and is the number of neutrons, or plus the number of neutrons. So again, you use this on a test. If it tells you it's the number of protons and the number of neutrons, you've got all the information you need to answer every question on the periodic table. Remember that the electrons do have mass, but they are so infinitesimally small that they don't count. Okay, so basically the mass of the atom is the mass of the protons plus the mass of the neutrons. So I want you, at this point, we're not going to talk about isotopes right now, but what I would like you to do is to look at your basic atomic structure handout. Okay? What I would like to do, I think, is to do one with each of you, or one with each of you. I would like to do one from each section with you so that you understand what you're doing. So I think 1 you should be able to handle. 2 through 6 I am going to help you with on the next video so that we don't have a very long video here, okay? Look down at number 9. Number 9 says, give the symbol of and the number of protons in one atom of those 8 elements. So lithium is right here. It's the first one. So you would write capital L, lowercase I, and then a 3 because it has a 3 here. And remember, the atomic number is the number of protons and it is the number of electrons. This is asking, give the symbol and the number of protons. So you would put capital L, lowercase I with a 3 for lithium. Okay? Number 10 says, give the symbol of and the number of electrons in a neutral atom of whatever, those 6. Okay? Well, remember, up here it says the atomic number also is the number of electrons. So uranium is right down here. Has a 92 in the corner, so it must have 92 electrons. So you would write a capital U and a 92. Not very hard, huh? All right. Now, for number 11, it says, give the symbol of and the number of neutrons and 1 atom of barium, for example, the first one. All right. So on our periodic table, it says that the atomic mass is the number of protons plus the number of neutrons. So the mass for barium is 56. I'm sorry. The mass is 137. If 56 is the number of protons, if you take 137 minus 56, you should get the number of neutrons. It's just a math problem. What plus 56 equals 137? Okay? So I think if you try to do 1, 9, 10, and 11, and possibly 12, we'll see. I will come back on and help you with the other questions, and I am going to give you the answers for 2 through 6 for the fill in the blanks, because those are not my words and I don't want to try to trick you in any way. All right? So you work on those and I will see you again later.